Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats, people. In the chats, every one of you. Good evening and welcome back. Good evening and welcome back. Good evening and welcome back. Quickly in the chats, if all of you can hear me, if I'm perfectly audible, visible to everyone. Just give me a second. All right, people. So I believe I'm perfectly audible, visible to everyone. So the duration of the today's session. Okay. A lot of students are asking about the duration. Well, this is going to be the most predicted chemistry paper, and we are just going to solve some 45 questions today, right? 45 questions means almost 1.5 hours. 1.5 hours I'll take, right, to complete these 45 questions. And this is going to be your most predicted paper of your chemistry. A lot of students are asking about the paper leak. They have seen some videos on Instagram. Guys, please and please leave Instagram right now. Okay, leave YouTube right now, wherein you are seeing these reels of again the paper leaking and stuff happening, right? So avoid it. Okay, it's going to divert your focus completely. Trust me on that. So avoid it right now. There is nothing like that. Okay, so this is not the time to look at these Instagram reels which are showing that paper again has been leaked, this has happened, that has happened. Nothing like that has officially been confirmed. Okay. You know, there are a lot of content creators on Instagram who just want views and, you know, likes, shares. So that is the reason why they come up with those sort of things. Or it might be true as well. Who knows? Nobody knows, right? But we are not going to waste our energy and time in that right now at this particular point of time. Okay. We are not going to do that. Okay, my dear students, the session which you are going to watch right now, right? The session which I'll be taking right now on this channel. Again, I'll tell you the same thing. You can expect the similar sort of questions in your upcoming NEET examination. I mean the Re-NEET examination. Questions directly, indirectly, you'll find of the similar pattern. Okay? All right? Questions directly, indirectly, you'll find of the similar pattern. And the ones who have not liked the session yet, I would want you guys to smash that like button right now so that this video reaches to majority of the audience, majority of the students who are going to write the Re-NEET examination, and they get benefited out of this session. Okay? Which you would never want. I'm pretty much sure about that. Yeah? Sir, I'm feeling like I'm forgetting everything. Everyone is feeling the same. Don't worry. Everyone is feeling the same. It is just a feeling. It's not the truth. It's not the reality. Okay? It's not the reality. The brain is tricking you. That's it. All right, should we start the session? I would want some fire emojis in the chats, every one of you. And the session duration, as I told you, 1.5 hours, that's it. But be with me till the end, because this particular session is going to be highly beneficial for all of you. Trust me on that. Okay? You will tell me after writing the Re-NEET examination for sure how much these sessions, which I took in the last week, were beneficial. So quickly in the chats, people, I just want to know whether you all are ready for the session. Yeah, I would want some fire emojis in the chats. I would want some fire emojis in the chats. One thing I'm assuring you, questions directly, indirectly will be from these small sessions, which I have been lately taking from past 3-4 days. Okay? Just be assured about that. Just be with me till the end, because the duration of the session is going to be 1.5 hours. That's it. And you'll be sorted. You will be sorted, people. Okay? So again, I would want some fire emojis in the chats if everyone is ready. Quick, people, quickly in the chats. Quickly in the chats. Everyone. Quickly in the chats. Everyone. All right. I'm going to start the session with one simple question that is going to be the confidence booster for all of you. And I would want you guys to write the answer in the chats, every one of you. My dear students, this is the question which is going to be the confidence booster for all of you. In your chemistry paper, you will find almost 10 to 15 easy kill questions which do not require pen and paper. By just looking at the question, you'll be able to solve the question. Tell me quickly, people. Tell me quickly, what do you think is the answer of this particular question? Arrange the following elements in the increasing order of the electronegativity. A very simple and basic question this is. Electronegativity order. You know, in your periodic table, fluorine is considered as maximum electronegative, followed by oxygen, followed by nitrogen. That's in your periodic table. Fluorine, maximum electronegative, followed by oxygen, followed by nitrogen. So fluorine, oxygen, nitrogen. The first option satisfies it. So it's definitely going to be option number 1. Okay? As I told you, it is definitely going to be the confidence booster for all of you. Okay? And deliberately, I came up with this particular question, which will at least boost up your confidence a bit. Because you are going to find these sort of questions also in your examination. These easy kill questions, which do not require any pen and paper. Okay? Just be assured. All right, people. Moving on to the next question. Look at this particular question from the chapter mole concept. My dear students, as far as this particular question is concerned, mass of magnesium required to produce 220 ml of hydrogen gas at STP on reaction with excess of dilute HCl. Okay. So as far as the question is concerned, magnesium is reacting with HCl. And when magnesium reacts with HCl, what does it form? It forms MgCl2, and with MgCl2, you get H2 gas. Okay. The reaction is balanced. Now, my dear students, as far as the question is concerned, what mass of magnesium is required? What mass of magnesium is required to produce 220 ml? To produce 220 ml of H2 gas at STP. Perfect. Now look at the question carefully. See if the reaction is balanced or not. Yes, the reaction is balanced. Yes, the reaction is balanced. Your first step always is to convert the given quantity into number of moles. So I'll say number of moles of H2 will be equal to given volume of H2 divided by 22400 ml. Because the condition is STP. Given volume of H2. Given volume in ml divided by 22400. So one of the zero gets cancelled out. So it's going to be 22 divided by 2240. These are the moles of H2. These are the moles of H2 which we are supposed to produce through this particular reaction. Now people, pretty much simple. Stoichiometric coefficient here is 1. The stoichiometric coefficient here also is 1. Now write the stoichiometric equation. You'll write number of moles of Mg divided by stoichiometric coefficient is equal to number of moles of H2 divided by stoichiometric coefficient. Divided by its stoichiometric coefficient. Perfect. So I can say moles of magnesium is nothing but it is moles of H2. And moles of H2 we have already calculated 222 divided by 2240. These are the moles of magnesium. If you got the moles of magnesium, you can calculate mass of magnesium as well. It's going to be moles of magnesium multiplied by molar mass of magnesium. The answer is going to be in grams. Let me exactly use the calculator because we do not have a lot of time to do the calculation stuff right now. Let me see exactly what it comes. 22 divided by 2240 is equal to this multiplied by 24. The value is coming out to be 0.235 grams. 0.235 grams, right? 0.235 grams. 0.235 grams. So multiply it with 1000. It is going to be 235 milligrams, right? If I multiply it with 1000, it is going to be 235 milligrams. So approximate answer is option number 4. Okay? The answer here is in grams, but I look at the option carefully. Don't write this one 0.24 directly. No, here it is in mg. It is 0.24 grams approximately, right? Here it is 0.24 mg. So it's not the answer. So you have to convert it into mg. You have to check other options. So it's option 4. That is going to be the correct answer of the question. Be careful with these small things. Moving on to the next question. Moving on to the next question, people. Look at this particular question. We are given with a reaction. 2A gives B plus C. The reaction is given. Its equilibrium constant is given. Let me write the reaction again. 2 times A, it gives B plus C. This is the reaction. Its equilibrium constant is given to us. Now, at a given time, the composition of the mixture is concentration of A is equal to concentration of B is equal to concentration of C. So at some time t, concentration of A as well as concentration of B as well as concentration of C is equal to how much? Is equal to 2 into 10 raised power minus 3 molar. Then, which of the following is correct? Reaction is at equilibrium. Reaction has tendency to go in forward direction, backward direction, and so on. How do I check it? My dear students, I will calculate the value of reaction quotient at time t. I'll calculate the value of reaction quotient at time t. And how do we get the value of reaction quotient? The similar way as we write the equilibrium constant expression. I'll write concentration of B at time t multiplied by concentration of C at time t divided by concentration of A at time t raised power stoichiometric coefficient. Now all these values at time t are given to me. This is 2 into 10 raised power minus 3. This is 2 into 10 raised power minus 3. This is 2 into 10 raised power minus 3 ka square. So the value directly comes out to be 1 because everything gets cancelled out. Okay. So my dear students, you got the QC value equal to 1. What is the value of KC? KC value is given in the question. How much is that? 4 into 10 raised power minus 3. 4 into 10 raised power minus 3. So I would say, my dear students, your QC is greater than KC. Your QC is greater than KC. And when QC is greater than KC, the reaction has got the tendency to go in the backward direction, right? So it's option number 3. That is going to be the correct answer of this particular question. Am I clear with this simple basic question based on reaction quotient? Expect this sort of a question in your examination as well. Everyone in the chats, everyone, is it clear? Is this question clear, people? Perfect. Moving on to one more question. My dear students, the question is from the chapter chemical bonding, and you are going to love this question because these sort of questions you most of the times practice, right, while doing the preparation. So tell me, what do you think will be the answer of this question? First of all, you have got NH3. If you talk about NH3, the type of the molecule is AB3L1. It is AB3L1 type. BRF5. The type of BRF5 would be AB5L1. XCF4. The type of the molecule will be AB4L2. This is XCF4. Okay. Similarly, SF6. It's going to be AB6L0. Now match the following. AB3L1. It is going to be pyramidal. Do you see any option? Trigonal, pyramidal, right? So A you are going to match with 1 directly. AB5L1, as you all must be knowing, AB5L1 means square pyramidal. So square pyramidal, right? AB4L2, that is square planar. AB6L0, that is octahedral. So match the following. You're done. Yes? Is that clear, people? A pretty simple question. You just have to identify the type of the molecule and you're sorted. Done with this? Everyone in the chats? I am moving on to one more question. It is option number 1 that's matching it. Look at this particular question, guys. Based on the data given below, the strongest reducing agent is. So tell me, reducing agent. My dear students, when it comes to your strongest reducing agent, that is directly proportional to SOP. Perfect. Now, first of all, look at all these values. Are these SOP values or SRP values? If I look carefully, chromium here is in +6 oxidation state. +6. And here chromium is in +3. +6 to +3. Decrease in oxidation state. Decrease in oxidation state means reduction. So it is technically SRP. Right? What do I need? I need SOP. Just change the sign. It's going to be -1.33 volt. Similarly, this is 0 to -1. 0 to -1 again, decrease, reduction. This is SRP. Change the sign. So this will be SOP. Right? Similarly, +7 to +2, decrease. This is SRP. So make it to SOP, -1.51 volt. +3 to 0, decrease. This again, SRP. So change it to SOP. Now tell me, which one do you think has got maximum SOP? There is only one positive number, 0.74, right? So I would say chromium has got maximum SOP. If chromium has got maximum SOP, I would say chromium is the better reducing agent, strong reducing agent among all. Yes? Option number 2 is the one that's correct among all. Pretty much simple. Moving on to the next question, people. A simple question. You love these sort of questions. Tell me, What do you think about this one? The highest number of helium atoms. 4 moles of helium means 4 Na atoms of helium. Right? 4 U of helium, 4 AMU of helium. 1 helium, 1 helium. What is the mass of 1 helium atom? That is 4U. So 4U of helium is 1 atom basically. This was 4 Na atoms. Perfect. 4 grams of helium means 1 mole of helium. 1 mole of helium means Na atoms of helium. Right? 2.27. Here you can convert, divide by 22.7, 0.1 moles. So it is 0.1 multiplied by Na. Right? Now, which one do you think is the maximum number? It's option 1. That's satisfying it. Again, these sort of questions we have done many a times, guys. So I'm not explaining this a bit in detail, right? Because this is understood. Because we know it. Okay? All right. Again, a confidence booster for all of you. Match the following, quick. Match the following. Isothermal process carried out at constant temperature. Do you believe this was the question asked in your JEE mains this year? Isochoric process carried out at constant volume. Isobaric process carried out at constant pressure. Adiabatic process, no heat exchange. So match, done. Again, the easy kill question I would say. The correct increasing order of bond angles. Now it is your turn to let me know the answer in the chats. Quickly. It is your turn to let me know the answer in the chats. Quickly. What do you think? What do you think, people? First of all, if you look at all these three, ClF3, ClF3, ClF3. Chlorine has got 2 lone pairs. Phosphorus has got 1 lone pair. BF3, boron does not have any lone pair. So tell me, what do you think about this one? Bond angle order. First of all, one thing is clear. BF3 will have maximum bond angle, 120. It is trigonal planar. It will be having maximum bond angle among all the 3, right? It's going to have maximum bond angle among all the 3, right? So I'll directly go with option number 1. But still, you can remember these values. Okay, you can remember these values. PF3 has a lone pair of electron. The angle here is around 96. In PF3, the angle here is around 96, right? And in case of ClF3, which is T-shaped, the angle is 90. You can remember it directly. You don't have to remember ClF3. It is a T-shape. That means it is going to be 90. It is going to be 90. PF3, you can remember, it's around 96. Moving on to the next question. What do you think about this one? SO2, NO2 negative, N3 negative. The hybridization of the central atom. For example, talk about SO2. Sulfur has got how many valence electrons? 6 valence electrons. How many surrounding atoms? 2. That means 2 sigma bonds. How many lone pairs on sulfur? 1 lone pair on sulfur. Steric number will be sigma plus lone pair. 2 plus 1, 3. Hybridization, sp2. Okay. NO2 negative. Nitrogen. How many valence electrons nitrogen has? 5. There is a negative charge. 5 plus 1, 6. Surrounding atoms 2. So sigma bonds 2. Right? Lone pair on nitrogen, that is 1. Steric number 2 plus 1, 3. Hybridization, sp2. And N3 negative is already, you must be knowing, it's linear. Linear means sp hybridized. Right? Now find the options and you're sorted. You're done. Correct, people? Moving on to the next question. Look at this one. The volume of 0.0 molar, the volume of 0.02 molar aqueous HBr. Required to neutralize what? 10 ml of 0.01 molar aqueous BaOH whole twice. So my dear students, if you look carefully, this is your acid, this is base. They are going to react. So this is the case of acid-base titration. And when we do the acid-base titration, what do? We use the equivalent concept. We can say milli-equivalence of HBr reacted would be equal to milli-equivalence of barium hydroxide reacted. Right? Whatever milli-equivalence of acid would have reacted, same milli-equivalence of base would have reacted. We know that already, as per the equivalent concept. Now, people, if I look at the values, what all values are given to us? HBr, its molarity is given, M1 value is equal to 0.02. We need to calculate its volume, V1. Molarity of barium hydroxide is given to me as how much? That is given to me as 0.01. Its volume is also given to me as 10 ml. Now, my dear students, one thing is clear. Barium hydroxide, its N factor will be 2. If its N factor is 2, normality will be molarity into N factor. 0.01 into 2, which comes out to be 0.02. Right? Now, the equivalence of both of them should be same. Milli equivalence of HBr will be equal to, normality of HBr multiplied by volume of HBr in ml. Similarly, milli equivalence of barium hydroxide will be equal to normality of barium hydroxide, volume of barium hydroxide in ml. So basically, you have to use N1V1 is equal to N2V2. Since the N factor of HBr is 1, if N factor of HBr is 1, its normality would be molarity into N factor, 0.02 into 1, that's 0.02 only. So my dear students, put the values. N1 value, 0.02. V1 needs to be calculated. N2 value, 0.02. V2 value, 10. So this term got cancelled. V1 value is coming out to be 10 ml. This is something I was supposed to calculate. So it is definitely going to be option number 3. That's the correct answer of the question. Understood, people? Everyone in the chats understood? It's pretty much simple. Your acid is reacting with base. So remember, milli equivalence of acid reacted would be equal to milli equivalence of base reacted. How do we calculate milli equivalence? Normality into volume in ml. So milli equivalence of acid, normality of acid, volume of acid is ml, is equal to milli equivalence of base, normality of base multiplied by volume of base in ml. That's all, right? And I just converted molarities into normalities. By which formula? Normality is equal to molarity multiplied by N factor. Pretty much simple. Expect these sort of questions. Moving on to the next. What do you think about this particular question, people? What do you think about this particular question? Everyone in the chats. Everyone in the chats. A heat engine carries 1 mole of an ideal monoatomic gas. Ideal monoatomic gas. If it is a monoatomic gas, 1 mole of ideal monoatomic gas, so N is equal to 1. Monoatomic means CV is equal to 3 by 2R. CP is equal to 5 by 2R. Because the gas is monoatomic. Undergoes the cycle. Select the correct option. So my dear students, if you look at the options, we have to calculate QAB and QCA. QAB and QCA. QAB and QCA. Right? If you look at the process AB, can I say during the process AB, volume is kept constant? During the process AB, volume is kept constant. So if I talk about AB process would be isochoric. AB process isochoric. So technically, if I'm supposed to calculate QAB, it means heat absorbed or released at constant volume. And you know heat absorbed or released at constant volume is nothing but delta U. And delta U for the ideal gas is nothing but NCV T2 minus T1. What is the value of N? N value is 1. CV value 3 by 2R. T2 minus T1. T2 here is 600. T1 is 300. So 600 minus 300 comes out to be 300 only. Right? So it's going to be 450R. So QAB is equal to 450R. QAB is equal to 450R. Now, QCA. If you talk about the CA process, during the process C to A, what is kept constant? Pressure is kept constant. So it's isobaric in nature. We have to calculate QCA. That means we have to calculate heat absorbed or released at constant pressure. And you know heat absorbed or released at constant pressure is nothing but delta H. And delta H for the ideal gas is NCP T2 minus T1. Now, N value is 1. CP value is 5 by 2R. T2 minus T1. See, C to A. This is now initial temperature. This is final temperature. Because C to A, initial, final. So final minus initial. 300 minus 450 comes out to be minus 150. Right? Now how much it comes out to be? It will come out to be minus 375 R. Is that? 5 into 150 will be 700 something. 700 something divided by 2 will be, yes, this much. So look at the options now. It's 450R and minus 375R. 450R and minus 375. So it's option number C, which is going to be the correct answer of the question. Remember just one thing. Heat absorbed or released at constant volume is equal to delta U, which is equal to NCV delta T. Heat absorbed or released at constant pressure is equal to delta H, which is equal to NCP delta T. That's all. Okay, that's all. One question which you are going to love, for sure. Tell me, what do you think about this one? The correct order of spin-only magnetic moment. My dear students, spin magnetic moment depends on number of unpaired electrons. It depends on number of unpaired electrons. More the unpaired electrons, more the spin magnetic moment. More the unpaired electrons, more the spin magnetic moment. Now, as I can see the options, if you look at option number 4, chromium. What is the outermost configuration of chromium? It is 3d54s1. But we are not given with chromium. We are given with chromium di positive. So take 2 electrons out. One from here, one from here. It becomes 3d4 configuration. 3d4 configuration will be something like this. 1, 2, 3, 4. So how many unpaired electrons? 4 unpaired electrons. Similarly, if you talk about chromium tripositive, you have to take 3 electrons out. 3 electrons out. 1 from here, 2 from here. It is 3d3 configuration. 3d3 configuration means 3 unpaired electrons. 1, 2, 3. So n value is equal to 3. Right? Similarly, you can check copper as well. So first of all, copper. Copper is 3d10, 4 is 1. Right? But they are giving copper dipositive. If you talk about copper dipositive, take 2 electrons out. 1 from here, 1 from here. It is 3d9. It is 3d9. Perfect. It is 3d9. And if you make 3d9 configuration, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is only 1 unpaired electron. Right? And Cu positive. Cu positive means take only 1 electron out. There is no unpaired electron. Right? So option 4 is definitely the one. That's the correct answer of the question. More the unpaired electrons, more the spin magnetic moment. That's all. That's all. Nothing more, nothing less. Sir, you are really 2x faster. I'm supposed to be fast right now, right? Because day after tomorrow is your exam. After 2 days, I mean. So we cannot afford to be slow at this point of time. You just have to see the pattern of the question, and that's it. All right, moving on to the next one. This question I showed in my yesterday's session as well. How many of you just remember the answer of this question? This question I showed in the yesterday's session as well. How many of you remember the answer of the question directly? Without solving? Quick. Absolutely. This question was solved in the yesterday's session, right? Perfect. Great. Great. Option number 4. All right. Moving on to the next one, guys. Look at this particular question. The question is an aqueous solution. That means the solvent uses water. An aqueous solution freezes at this particular temperature. So this is the freezing point of the solution. Kf value is given. Now you know delta Tf. Delta Tf. What is delta Tf first of all? It is freezing point of solvent minus freezing point of solution. Delta Tf is nothing but Kf multiplied by m. Delta Tf is nothing but Kf multiplied by m. You must be knowing that. Okay, you must be knowing that. Now, freezing point of solvent, since it's mentioned as aqueous, so freezing point of water is 0. So this term is 0. Minus Tf of solution is equal to this. So I'll write minus Tf of solution is equal to Kf value. Kf value is given to me as 1.86 multiplied by molarity. Correct? Freezing point of solution is also given to me in the question. How much? Freezing point of the solution is given to me as, this is already minus here, minus makes it plus. So it is 0.186. Perfect. 0.186. So molality will come out to be 0.186 divided by 1.86. 0.1. You got the molality of the solution. If you got the molality of the solution, we have to calculate what? Elevation in boiling point. Elevation in boiling point is nothing but delta Tb, which is nothing but Kb multiplied by m. Since we have already calculated molality, Kb value is given as 0.512 multiplied by m value, we calculate as 0.1. The answer is 0.0512. This is the elevation in boiling point. This is plus here. Okay, this is a mistake. Perfect, guys. Clear to everyone? Am I clear, people? Everyone in the chats? All right. Moving on to the next one, people. Moving on to the next one. This sort of a question you saw in your 3rd May examination as well. Okay? Have a look on this. You know it. In which of the following Kp and Kc are not equal? When is Kp, Kc equal? First of all, you should know Kp and Kc are equal only if delta Ng is 0. And Kp and Kc are not equal when delta Ng is non-zero. So you have to find the reaction whose delta Ng is non-zero. So which reaction is that whose delta Ng is non-zero? That is option number 3. Look at this particular reaction. Its delta Ng is equal to 1. And if delta Ng is equal to 1, that means non-zero. Kp and Kc won't be equal. Done and dusted. Right? Moving on to the next question, people. Moving on to the next question. Moving on to the next question. A simpler one. Tell me. Quickly in the charts. The number of radial nodes. Radial means spherical. Radial or spherical nodes is same, right? How do we calculate it? N minus L minus 1. Yesterday only I've taught you this. N value here is 3. For P subshell, the value of L is 1. So it is 3 minus 1 minus 1. So the value comes out to be 1. Right? Perfectly done. Perfectly done, people. Absolutely, it's option number 4. That's the correct answer. I am moving on to... Wait, did I do some mistake here? No, right? Okay, moving on. Moving on. The correct order of increasing first ionization enthalpy. What will be the order of ionization enthalpy here? What would be the order of ionization enthalpy here? First of all, ionization enthalpy of argon will be maximum because that's group 18, noble gas. Their ionization energies are maximum. Correct? Now, sulfur and Sc, they belong to group 16. They belong to group 16. And in group 16, sulfur has got maximum ionization energy. In group 16, sulfur has got maximum ionization energy. You know that already, right? So sulfur comes, then it's going to be Sc. Perfect. So it's going to be first option only. That's matching everything. Done? I am moving on to one more question, guys. Look at this one. Look at this one. Look at this one. In a first order decomposition reaction, time taken for the decomposition of the reactant to 1/4 and 1/8 of its initial concentrations are T1 and T2 respectively. The ratio of T1 and T2 will be. Okay. Now, let's try to understand how to deal with this sort of a question. You're given with a reaction, for example, A gives B. Let's say at time T is equal to 0, the initial concentration of reactant is A0, this is 0. Now, there are two times given, T1 and T2. T1 is the time when the concentration of reactant left is A0 by 4. And T2 is the time when the concentration of reactant left is A0 by 8 as per the question. T1 is the time when the concentration of reactant left is A0 by 4. T2 is the time when the concentration of reactant left is A0 by 8. And you know concentration of reactant left is represented by 80. That is represented by 80. Now, what is my integrate rate equation? I can write integrate rate equation like this. T is equal to 2.303 divided by K. It's going to be log of A0 divided by 80. Correct? If I use this particular condition, in this equation, instead of T, I'll write T1 is equal to 2.303 divided by K log of A0 divided by, what is 80 value here? That is A0 by 4. So A0 not cancels out, 4 comes up. 4 comes up. 4 is 2 ka square. Log of m raised power n is n log m. So 2 comes to the front. 2 comes to the front, then it's log of 2. Let me keep the equation as equation number 1. Now, if I use this particular condition in the same equation, instead of T, I'll write T2 is equal to 2.303 divided by K log of A0 divided by, what is 80 value right here? That is A0 by 8. So A0 cancels out, 8 comes up. 8 comes up means 2 raised power 3. Log of m raised power n is n log m. So 3 comes front, then it's log of 2. I'm calling this equation number 2. What do we have to calculate? We have to calculate T1 by T2. So divide the 2. T1 divided by T2 is equal to this term cancels out, this term cancels out. So it's 2 by 3. That is the final answer of the question. Understood, people? Done and dusted? Just with the help of one equation, right, we solve the question. All right. In order to solve this question, I've already given you one result, one direct result. See, we are given with molarity, we have to calculate molality. If you do not remember the result, then remember it right now. Molality is equal to 1000 multiplied by molarity divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute. Okay? All the things are given to us. See, 1000 I'm writing as such. Molarity of the solution is 3 divided by 1000 into density of solution is how much? 1.25. So 1.25 into 1000 becomes 1250 minus molarity is 3 multiplied by molar mass of solute, molar mass of NaCl will be 58.5. Again, the matter of calculation, solve it and get the answer. The point is, just remember this particular result. That's all. Just remember this particular result. Quick. Okay? I believe I'm clear with this. Okay. The molar solubility S of zirconium phosphate, it is Zr3. That is given over here as well. Zr3 PO4 whole 4. This is your zirconium phosphate. Perfect. We have to write its solubility in terms of KSP. Now, how do I write it? First of all, how do you dissociate it? How do you dissociate it? This 4 goes here as a charge. This 3 goes here as a charge. Now, how many zirconiums we have? 3. This zirconium is in +4 state. Plus, how many phosphates we have? 4. And it's in -3 state. Perfect. And aqueous, you know it. If the solubility of this is S, this becomes 3 times S, this becomes 4 times S. Now, when you write the KSP expression, it's going to be concentration of zirconium, that is 3S, raised power stoichiometric coefficient 3. Concentration of phosphate, that's 4S, raised power stoichiometric coefficient 4. So it's S raised power 4, S raised power 3, S raised power 7, S raised power 7. 3 raised power 3 into 4 raised power 4 into S raised power 7 is the value of KSP, right? Is the value of KSP. Now, I can say your S would be equal to KSP divided by 3 raised power 3 multiplied by 4 raised power 4 whole raised power 1 by 7. Now, it is a matter of calculation here. It is a matter of calculation here. 1 raised power 7 is the power here, 1 raised power 7 is the power here. So, it's either going to be 1 or 2. So, which one is it? When you calculate it, it is going to be option number 2. That is the correct answer of the question. Okay? That is the correct answer of the question. I believe I'm clear with this. I believe I'm clear with this. Yes? Okay. One more simple question. Tell me, what do you think about this one? Tell me, what do you think about this one? The transition metal having highest third ionization energy. Which one has got highest third ionization energy? If you talk about manganese, my dear students, what is the outermost configuration of manganese? It is 3d5 4s2. It is 3d5 4s2. If I talk about third ionization energy, that means you are going to take the third electron out. That means 2 electrons are already out. Now you have to take the third electron out. Third electron you are taking from 3d5 configuration. Third electron you are taking from 3d5 configuration, which is half-filled configuration, stable configuration. So this will have maximum third ionization energy. Right? Done, people? Look at this particular question. Yes, I'm modifying the question. It's irreversibly. Look at the question carefully. 1 mole of an ideal gas. 1 mole of an ideal gas is allowed to expand irreversibly and adiabatically. Adiabatic and irreversible. From a temperature of 27 degrees centigrade. Initial temperature is 27 degrees centigrade, 300 Kelvin. Work done is equal to 3 kilojoules. Work done is equal to 3 kilojoules. Calculate the final temperature. We have to calculate T2 value. We have to calculate T2 value. 1 mole of an ideal gas is allowed to expand. Is allowed to expand. So the gas is undergoing expansion. And when the gas undergoes expansion, W value is taken as negative. So W I have to take as -3 kilojoules. Okay. Now, since the process is adiabatic, when it comes to adiabatic processes, delta U is equal to W because Q value is 0. Delta U is nothing but NCV T2 minus T1. Right? W value is given in the question. That is -3. Since everything is in joules, so write it as 3000 joules. N value is 1. CV value is given to us as 20. T2 we have to calculate. T1 is 300 is equal to -3000 here. Now you can do the calculation and you can get the value of T2 from here. Right? You can get the value of T2 from here. I believe I'm clear with this. I believe I'm clear with this, people. Clear? Did you understand? Everyone, just see the approach, how I'm solving the question. That's it. We were supposed to calculate T2, final temperature, and you have calculated the final temperature from here. Now, a bit of calculation is required, and you are done. This 0 gets cancelled. This becomes -150. 300 goes that side. So that becomes +300. So the answer will be 150 Kelvin. This is the final temperature of the gas. Yeah? Okay. One more question, people. Tell me, what do you think is the answer of this question? Till then, I'm going to call KK sir. I'll tell him to be ready with the organic questions. I'll tell him to be ready with the organic questions. Tell me the answer of this question till then. Okay. Quickly, people. The question is, which of the following graphs most appropriately represents the zero order kinetics? Now, which graph is going to represent the zero order reaction? Concentration versus time. Rate versus time. Rate versus time. Concentration of reactant versus time. If you remember your zero order reaction, your integrated equation says that AT is equal to A naught minus KT. AT is equal to A naught minus KT. This is the concentration of reactant, which you are plotting along y-axis. Time you are plotting along x-axis. This K becomes your M. Sign is minus. This is C. Y is equal to minus mx plus C. The graph is a straight line with a negative slope. So this particular graph represents straight line with negative slope. It represents your zero order reaction. It represents your zero order reaction. What do you think is the answer of this one? Quickly, be quick. Choose the option having all the elements with D10 configuration. Which all elements will have D10 configuration? Copper will have D10, 3D10-4s1, 3D10-4s2. So all these here, cadmium, silver, they'll have D10 configuration. Right? Okay. Moving on to the next one. This sort of a question is frequently asked. You know that already. I've told you this in many of the sessions. Right? Calculate the temperature above which, below which the reaction will be spontaneous, etc., etc. Now, let's try to understand how do we deal with this question. The reaction is given, delta H is given, delta S is also given. The reaction will be spontaneous at. For the reaction to be spontaneous, delta G for the system should be negative. Delta G is nothing but delta H minus T delta S. This has to be negative. That means delta H should be less than T delta S. Or I can say T delta S should be greater than delta H. Or I can say T should be greater than delta H divided by delta S. Right? Now, delta H is given. How much? 400 kilojoules. 400 kilojoules. So 400,000 joules divided by delta S is 0.2 kilojoules into 1000. So it is 200. Perfect. 0, 0 cancels. This is 2, 1, 2000. So temperature should be greater than 2000 Kelvin. The reaction is going to be spontaneous. Perfect. It's option A, people. Simple process and you're done. Simple process and you're done. And these are most repeated questions. Tell me, a pretty simple question from your MOT. The number of anti-bonding electrons in O2. Well, you can only count the anti-bonding electrons if you know the molecular orbital configuration of O2. And my dear students, just know molecular orbital configuration of O2 is this. Since O2 has got total 8, 8, 16 electrons, so it's a 16 electron species. So 2, 4, 6, 8, 10, 12, 14, 15, 16. In total 16 electrons. Now we are supposed to check the anti-bonding electrons. See, all these ones which are having star, these are your anti-bonding molecular orbitals. Anti-bonding molecular orbitals. So 2 here, 4, 5 and 6. So in total there are 6 anti-bonding electrons in O2. You should know it directly. You should know it directly. There are 6 anti-bonding electrons. Alright, what do you think about this one? The spin-only magnetic moment of FeCN6 trinegative is 1.74, which is true because Cn negative is the strong field ligand. It is going to cause the pairing of electrons. If it is causing the pairing of electrons, the spin magnetic moment will be less, right? Which will be 1.74 only, that's correct. Whereas FeH2O6 3 positive. Since H2O here, this is a weak field ligand, it's not going to cause pairing, though magnetic moment will be more, so this right only. So statement 1 is right. In both the complexes, Fe is in +3 oxidation state. Fe here is in +3. Here also Fe is in +3. That's also right. So statement 1 is right, statement 2 is right. But statement 2 is not the correct explanation of statement 1. Right? Statement 1 is right, statement 2 is right. But 2 is not the correct explanation of 1. So I'll go with option number 3. I will go with option number 3. Okay. Again, a simple question. And a lot of students, they do mistakes while solving these simple questions. What do you think about this one? 3 moles of ideal gas, N is equal to 3, are compressed isothermally from 60 liters to 20 liters. So 60 liters to 20 liters. Using constant pressure. Using constant pressure of how much? 5 atm. Heat exchanged. We have to calculate Q value. Pretty much simple question, guys. You should kill it. First of all, if you look carefully, the process is isothermal. And you know when the ideal gas undergoes isothermal process, delta U is equal to 0. When the ideal gas undergoes isothermal process, delta U is equal to 0. Now delta U is equal to Q plus W. So this value has to be 0. That means Q has to be equal to minus W. So technically I have to get the W value first. And how do I calculate W? You know it. Minus P external delta V, which is V2 minus V1. P external is 5 atm. V2 minus V1. V2 minus V1. That comes out to be minus 40. V2 minus V1 minus 40. So this will be 200 atm liter. 200 atm liter, right? If W is equal to 200 atm liter, that means Q will be equal to minus 200. Wait, let me read the question again. 3 moles of an ideal gas are compressed isothermally. You know, when the gas undergoes compression, isothermal compression, heat is released by the gas. That means Q value has to be negative only. Yes, correct. So Q will be equal to minus 200 atm liter. Q will be equal to minus 200 atm liter. But right now they have only given the magnitude, right? So go with that. Go with that. Okay? Perfectly done. If it is perfectly done, then tell me the answer of this question. This is our last question of the session, people. After this, your KK sir is joining in. Tell me the answer of this question. Henry's constant of ABC is given. ABC is given. Henry's constant 145, 2 into 10 raised power minus 5 and 35 kilobar respectively. The solubility of these gases. The solubility of these gases. Right? Tell me the answer of this question. More than Henry's constant. More than Henry's constant. Lesser is the solubility. More than Henry's constant, lesser is the solubility. You should know it. Now, check where is the Henry's constant maximum. So, its solubility would be minimum. Right? So, here you can see 145 kilobar. This is the maximum Henry's constant. Maximum Henry's constant means minimum solubility. So, that's why A is having minimum solubility over here. Okay? Perfect, Pike. Perfect, guys. So, these were some important questions. Right? Some of them were basic, some of them were moderate, right? Now it's going to be the time for your organic chemistry questions, right? Now your KK sir is joining in and he is going to start organic chemistry discussion with all of you, okay?
Hello, my dear lovely students. I believe you all are doing good and having a great time. But before we move ahead, please let me know in the chats if I am clearly audible and visible to each and every one among you. Let me know in the chats if I am perfectly audible and visible to each one of you. Let me know in the chats if I am perfectly audible and visible to each one of you. Okay, dear students, it's all right. We are live now. Now, let me tell you today's session, we are going to discuss few very amazing questions. So without wasting time, let's get started. So let's begin our session with the question number 1 like this. Question says that CH3CH2OH. Question says like this. It is CH3CH2 and in its OH, this upon treatment with PCC. What is PCC? This is pyridinium chlorochromate, which is basically a mild oxidizing agent. It results in the formation of A. Now, you know, this is a primary alcohol. Primary alcohol on treatment with PCC means pyridinium chlorochromate results in the formation of an aldehyde. So it gives us an aldehyde first. That aldehyde, so this is A, upon treatment with HCN, dear students, what will happen? It results in the formation of B. We know this is simply having a positive part, this is simply negative part, this is positive part, this is negative part. So this is normal nucleophilic addition reaction. Negative part goes to positive, positive goes to negative. In nutshell, we will obtain here a cyanohydrin. We will obtain a cyanohydrin here. So this is, my dear students, B. Now this cyanohydrin upon hydrolysis, remember, when cyanohydrin undergoes hydrolysis, it is the CN which gets changed to COOH. That means it will result in the formation of CHOH, and this CN is converted to COOH. Now, this is CH3, CHOH and COOH. That means option first is the right answer. Option first is the right answer. Exactly. Now, dear students, there is another question. C6H6 means this is benzene. means this is benzene. Benzene on treatment with methyl chloride, CH3Cl, in presence of AlCl3. We know this is known as Friedel-Crafts alkylation reaction, and here CH3 positive will be the electrophile. Normal electrophilic substitution reaction takes place, so it results in the formation of methyl benzene known as toluene here. So this is, my dear students, A. After this, toluene on treatment with KMnO4 followed by acidification. You know, this CH3 is oxidized to COOH. That means we will obtain benzoic acid over here, and this is, my dear students, B. Now this benzoic acid on treatment with SOCl2, thionyl chloride. Whenever there is acid and thionyl chloride, just replace OH by Cl. Just replace OH by Cl and we get benzoyl chloride. That means this is C. We have to identify C. So this is C6H5COCl. C6H5COCl is this one. So B is the right answer, dear students. After this, another question. C6H5NH2 means this is aniline. Means this is aniline. Aniline on treatment with NaNO2HCl. That means this is diazotization reaction, and we know diazotization reaction takes place at low temperature. Now, what will happen? Diazonium salt will be obtained over here. So we will get benzene diazonium chloride over here. Now, this is A. This benzene diazonium chloride on treatment with CuCl. This is Sandmeyer's reaction. We know here cuprous chloride. Here N2 will be replaced by chlorine, that means by halogen, which is attached to this copper. So we will get chlorobenzene over here. So this is B. We have to identify B. So B is C6H5Cl. C6H5Cl is B. I hope this point is also clear. After that, we have another reaction, and reaction is like this. CH3COOH, that means acetic acid or ethanoic acid. This on treatment with thionyl chloride. Once again, thionyl chloride and acid is there. Replace OH by Cl. So we will get CH3, C double bond OCl. We will get acetyl chloride. So this is A, dear students. Now, this acetyl chloride on treatment with ammonia. What will happen? Replace this Cl by NH2. So we will get CH3CONH2. Acetamide will be the product B. So what is B? CH3CONH2. So it is option number A. Great, great. Many students are giving me the right answer. God bless you. Now, another is C6H5Br. That means it is bromobenzene. This bromobenzene on treatment with magnesium in presence of ether. Now listen, whenever there is CX bond and magnesium is there, magnesium comes in between C and X bond. That means we will get phenyl magnesium bromide, which is a Grignard's reagent. Now this is what we call our A, but we know this is having a negative part and MgBr is a positive part. Now remember, this on treatment with carbon dioxide. Remember, this negative part will attack carbon dioxide and we will obtain first like this, C double bond O and then O having negative charge, and to this negative charge, it will be MgBr having a positive charge. Finally, this upon hydrolysis will yield simply like this. It will result in the formation of benzoic acid plus it is MgBr to this Mg. It will be OH. So we will get C6H5COOH. That means it is option number B. This is option number B. Now, let me know quickly the answer of this question. Let me know quickly the answer of this question. Come on. Let me know the answer of this question quickly in the chats. We'll be waiting for this answer. This is very, very, very simple answer. Come on. Tell me the answer of this question. Come on, my dear lovely students. Come on. Come on, quick. Okay, have a look. This is very, very simple question. These are sequence reactions. You have to work on sequence reactions. You have to work on reagents as well. Now, have a look. This is C2H5Br. So I can write down CH3CH2Br. It's ethyl bromide. When treated with alcoholic potassium hydroxide, listen carefully. When it is alcoholic, then it is elimination. When it is aqueous, then it is SN2 reaction. So this is simply E2 reaction. And in E2, what we have to remove? Remove halogen from alpha, remove hydrogen from beta. So we will obtain an alkene here. This is dehydrohalogenation reaction. So this is A. Now, this A is treated with bromine. in presence of CCl4. What is this? This is simply electrophilic addition reaction. So we will get like this. We will get vicinal dibromide over here. Vicinal dibromide will be obtained. That means we will obtain BrCH2CH2Br. That means option A. After this, we have another question, my dear lovely students. A very simple question. Phenol is there. We know this is phenol. Phenol on treatment with chloroform in basic medium. We know this one. We know this one. This will result in the formation of, because this reaction is Reimer-Tiemann reaction, followed by, I mean to say acidification. So it finally results in the formation of orthohydroxybenzaldehyde. That means we will get salicylaldehyde. And reaction is known as, Reimer-Tiemann reaction. Now, this salicylaldehyde upon oxidation, remember my dear lovely students, it is the CHO which gets oxidized to, say COH. So we will get here what we call salicylic acid or orthohydroxybenzoic acid. So this is our, product. So this is our B. We have to identify B. This is A. You have to identify B. So here it is C6H4, then OH and COH. That means C6H4, OH and COH. It is option number A. After that, we have another question. Question is like this. CH3, C double bond OH. That means this is an aldehyde. On treatment with sodium borohydride. What is sodium borohydride? A reducing agent which can convert this C double bond O into C single bond HOH. That means you have to break this bond, give hydrogen to this, give hydrogen to this. You will get CH3. Now this is CH and H. That means it becomes CH2. Then this is single bond OH. That means alcohol is obtained from this aldehyde. Primary alcohol will be obtained. So this is A. Now this A on treatment with PCC, pyridinium chlorochromate, another name is Corey's reagent, convert this primary alcohol to aldehyde. That means this is oxidation. So we will get CH3CHO. I hope this point is clear. That means from CH3CHO, we finally get CH3CHO as well. That means our product is simply this one. First, it is reduction, then it is oxidation. This is a mild oxidizing agent. Now, after that, C2H5OH. That means CH3, CH2, OH is there. And alcohol is there. This on treatment with PBr3. What will happen? This OH will be replaced by halogen. That means we will get CH3, CH2 and Br. So this is our A. Now my dear lovely students, this on treatment with KCN. This is normal SN2 reaction. And major product will be replace Br by Cn. Replace Br by Cn, replace halogen. Whenever there is CX bond and KCN is there, replace X by Cn. So we will get cyanide over here. So this is what we call RB. This is product B. But this upon hydrolysis, remember, if hydrolysis is written, then you have to convert Cn to COH. If partial hydrolysis is given, then convert Cn to CONH2, that means amide. But it is hydrolysis over here, so you have to convert CN, cyanide, to carboxylic acid. So this is our C. You have to identify C. So C is C3, C2H5, C2H5COH. That means it's option number B. It is option number B. After that, a very good question is this. This is benzene. Benzene on treatment with nitric acid and sulfuric acid. Remember, this is what we call a nitrating mixture. Here, sulfuric acid will act as an acid, HNO3 will act as a base, and NO2 positive is generated as an electrophile from this nitric acid with the help of H2SO4. So NO2 positive is an electrophile. So we will get what we call nitrobenzene over here. So this is A. Then, so this is nitration of benzene. Nitrobenzene is obtained. Then nitrobenzene is treated with SnHCl, a reducing agent which converts NO2 to NH2. So we will get aniline or aromatic primary amine, and its formula is C6H5NH2. So this is what we call our B. We have to identify B. So B is what we call C6H5NH2. Once again, option B is the right answer. After that, dear students, this is a question. This is the question. CH3CONH2. This is known as primary amide. This is primary amide. Primary amide on treatment with Br2 and base. This is known as Hoffman's bromamide degradation, or Hoffman's what we call degradation reaction, or simply Hoffman's rearrangement reaction. What we have to do is we have to remove C double bond O, and we will get primary amine from primary amide, but one carbon lesser than primary amide. So CH3NH2 is the right answer. That means it's option number A. It is option number A, and reaction is known as Hoffman bromamide reaction. After that, dear students, we have another reaction like this. Benzene is there, and CH3COCl is there. That means acetyl chloride is there in presence of AlCl3 anhydrous. We know this reaction is known as Friedel-Crafts acylation reaction. AlCl3 will remove this Cl, and finally we will get a carbocation like this. This is an electrophile, and this electrophile is introduced into benzene ring, and we will get acetophenone like this. It is C double bond O, this one, and then it is CH3. So acetophenone will be obtained. Reaction is known as Friedel-Crafts acylation. After that, dear students, as this is the ketone or aldehyde on treatment with zinc amalgam HCl, reaction is known as Clemmensen reduction, and you have to convert this C double bond O to CH2, and finally we will get ethyl benzene. That means this is converted to CH2, and then it is CH3. So it is ethyl benzene. That means it's C6H5 CH2 CH3. That means option number B is the correct answer. So this is A and this is B. We have to identify B, and B is C6H5CH2CH3 means ethyl benzene. Now tell me what will be the answer of this question. Come on, tell me what will be the answer of this question. Everyone, quick. What will be the answer of this question? These types of questions, you will see these types of questions on 21st June. So be ready for sequence type of reactions, and be ready for, say different functions of different reagents, and be ready for, say different tests which are used in organic chemistry, and be ready for named reactions as well. So you have to be very much strong as per your NCERT textbook is concerned. Now, come on, tell me what will be the answer of this question. Come on, everyone. Okay, have a look. It is C2H5. That means this is CH3CH2COOH. So it is like this. After this, it is treated with lithium aluminium hydride, a reducing agent, which converts this COOH group to CH2OH. That means it will result in the formation of C2H5. Then it is CH2OH. Once again, a primary alcohol. This primary alcohol is A. This on treatment with PCC. Once again, this PCC is a mild oxidizing agent and converts primary alcohol to aldehyde, secondary alcohol to ketone. So this is primary alcohol. So we will get C2H5, and then it is CHO. Then it is CHO. So it is C2H5CHO. C2H5CHO is the option A. Now, my dear lovely students, there is another question, a very simple question. Question says you have ethene. This upon oxidation by using ozone and zinc. That means this is reductive ozonolysis. You have to tell me what is A. We know you have to break this, give double bond oxygen to this, double bond oxygen to this. That means we will get a formaldehyde over here. 2 moles of formaldehyde will be obtained. That means formaldehyde will be obtained as A. Now, this formaldehyde upon reduction with NaBH4, you know this is aldehyde. When NaBH4 is there, it can reduce this C double bond O to CHOH. That means you have to break this one, add H here, add H here. So it is CHH and H. That means CH3 single bond OH. That means we will obtain CH3OH over here. So it is option number 1. Very, very simple. Now tell me, my dear lovely students, another question is a very simple question. C6H5CN, that means it is benzonitrile. Now it is Stephen's reduction. Stephen reduction means it is SnCl2HCl followed by say hydrolysis. Now what will be the product? Convert Cn to CHO. That means we will get benzaldehyde over here. So this is A. Now, this benzaldehyde on treatment with NaBH4. We know NaBH4 can convert aldehyde to CH2OH group. So, we will get benzyl alcohol over here. So, this is B. Benzyl alcohol is obtained. Means C6H5CH2OH. That means it's option number B. After this, dear students, another question. Phenol is there. Then it is treated with NaOH and CO2, or CO2 and NaOH, followed by acidification, because it results in the formation of A first. What is A? A is simply like this. It is OH and COONA. Now this is A. After that, acidification, it results in the formation of a product. And what is that product? We know product is salicylic acid, and this reaction is known as Kolbe-Schmidt reaction. So this is the product. Salicylic acid is the product, and we have to identify what is product. Product is salicylic acid. That means product is C6H4OH and COH, and this is option number 1. Salicylic acid is the product of Kolbe-Schmidt reaction. Now, after this, my dear lovely students, it is CH3, C double bond O, OH. Remember, when it is treated with ammonia, it first results in the formation of ammonium salt of carboxylic acid, but upon heating, it loses water molecule and it results in the formation of what we call amide. First, it forms ammonium salt of carboxylic acid, then ammonium salt of carboxylic acid will lose water and it will result in the formation of primary amide. So this is A. This primary amide, once again, on treatment with Br2KOH, that means Hoffman degradation reaction, you have to remove C double bond O and we will get CH3NH2 as the product. That means as B. We have to identify B, and B is CH3NH2, my dear students. Now, dear lovely students, another question is chlorobenzene, C6H5Cl. It is chlorobenzene, dear students. This chlorobenzene, my dear lovely students, on treatment with NaOH at a temperature of 623 Kelvin, 300 atmospheric pressure, you know, results in the formation of sodium phenoxide first. And this sodium phenoxide on acidification results in the formation of phenol, and we know this reaction is known as Dow's process. That means final product of this reaction is basically phenol. That means C6H5 and then OH. C6H5OH is the final product. So final product is the phenol, my dear lovely students. After that, tell me what will be the product of this reaction. Come on, tell me the product of this reaction. Come on, tell me product of this reaction. Quick. What will be the product of this reaction? Very, very simple reaction. Very, very, very simple reaction. Very good, very good, very good. Nice, nice. Have a look. This is what we call acetylene or ethine. This ethine upon hydration, hydration of alkyne, is known as Koch-Arrows reaction. So this is Koch-Arrows reaction. So what will happen? It first results in the formation of this aldehyde. So this is a, once again, aldehyde on reduction with sodium borohydride or lithium aluminium hydride or sodium in alcohol or H2 in catalyst. We know it converts this CHO to CH2OH. That means it is C2H5OH, which is the right answer. So option A is the right answer. Dear students, after this, here is toluene, methyl benzene, C6H5CH3. Toluene is there. This toluene on treatment with CrO2Cl2, that means chromyl chloride in CS2, followed by hydrolysis, it results in the formation of benzaldehyde, and reaction is known as Itard's reaction. So this is A. This Itard's reaction product, that means benzaldehyde, upon reduction, once again, it is aldehyde and sodium borohydride. What is the function of sodium borohydride? It can reduce aldehyde to alcohol. So it will result in the formation of benzyl alcohol. That means B is benzyl alcohol. That means C6H5CH2OH, which clearly indicates it is option number A. After this, dear students, have a look. Here it is acetone, it is dimethyl ketone or propanone, which on treatment with NH2 means hydrazine in basic medium. So this is Wolff-Kishner reduction. What we have to do? We have to convert C double bond O during Wolff-Kishner reduction to CH2. That clearly indicates it's propane. Propane is having a molecular formula C3H8, which clearly indicates it's option number A. After this, dear students, another question is aniline. Aniline means this one, C6H5NH2. This aniline upon acetylation, that means on treatment with, say for example, acetic anhydride, what will happen? What will happen on treatment with acetic anhydride? Replace H by COCH3. That means acetylation will take place. We have introduced COCH3. We have introduced CH3, that means acetyl group at this position by replacing H. So this is what we call acetanilide. This is known as acetanilide. So this is a upon nitration, which clearly means upon treatment with HNO3 concentrated and H2SO4. Now what will happen? What will happen? Where NO2 positive goes? NO2 positive can be introduced to ortho as well as para position, but para 1 will be the major product. Para 1 will be the major product. Para 1 will be the major product. So this is acetanilide, and to this acetanilide, this NO2 goes to para position. So para acetanilide will be the major product. So para acetanilide will be the major product, my dear lovely students. Then dear students, another question is, we have benzaldehyde. We have, dear students, benzaldehyde. Benzaldehyde on treatment with HCN. A nucleophilic addition reaction is this one. Once again, this is partial, positive, negative, positive, negative. Give negative to positive, positive to negative. So we will get cyanohydrin first. We will get cyanohydrin first, like this. We will get cyanohydrin first. Now once again, hydrolysis. Then what will happen? Convert CN upon hydrolysis to COH. So we will get this product. We will get this product. So it is CH, this is OH, and this is COOH. Very, very simple reaction is this. So it is C6H5 CHOH COOH. That means it is option number A. Option number A. Very, very simple. After this, we are having alcohol CH3OH. On treatment with thionyl chloride, replace OH by Cl. So we will get CH3Cl as product A. Now this upon treatment with KCN, what will happen? Now what will happen? CN will replace Cl. So we will get CH3CN. We will get CH3CN as B. So you have to identify what is B. B is CH3CN, means option number A is the right answer. Okay. After this, there is C2H5Br, means CH3CH2Br. Now this on treatment with KCN, a normal SN2 reaction is this. So replace Br by Cn. So we will get CH3, CH2, C triple bond N. That means we will obtain a cyanide over here. This cyanide upon hydrolysis, what will be the product? What will be the product? Convert Cn to COH. So product will be CH3, CH2, COOH, dear students. So this is B. You have to identify B. That is C2H5COH. That means it's option number A. I hope, dear students, that this is fruitful for you, because if these are very, very, very important reactions as per sequence reactions are concerned. So this is all from my side today. So thank you and God bless you all. And I wish you a very, very good luck. I wish you all to be present. You all to be present in GMCs, and that too on 21st June. I wish that you will come out victorious on 21st June. So this is all about today's session. Thank you and God bless you all. Love you all. Take care. Bye-bye. But before ending the session, I would want you all guys to comment after ending the session from where you were watching this session. So bye-bye. Take care and love you all.